Hi, in this question, we want to apply the Ford-Ferguson algorithm to determine the value of a maximum flow from the source X to the sink Y in the following network. Here's the first one. To do this systematically, we're going to have the following table, where in the first column we have the path Q, which is an F incrementing path in the network from the source X to the sink Y. In the second column, we have the residue capacities of all the forward arcs in the path Q. And in the next column, we have the flow on the reverse arc, if any, on the path Q. And in the last column, we have epsilon Q, which is the minimum of the numbers that we get in the second and the third column. And epsilon Q is the amount that we can use to increase the existing flow. Alright, let us now start by finding an F incrementing path. Well, this can be given by the path X going to A, and then B, and then Y. This path is F incrementing because all the arcs in the path are forward arcs, and the current flow is strictly less than the capacity. And therefore, the residue capacity on the first arc is just 3, which is 3 minus 0. The residue capacity on the second arc is 1 minus 0, which is 1. And for the last arc, the difference is 3 minus 0, which is 3. There are no reverse arc on the path, so there's no number here in the third column. So epsilon Q, which is the minimum of these numbers, is just 1. Therefore, we can increase the value of the flow by 1. And let us do that now by revising the flow. So the 0 here will become 1. Okay. Next, we try to find another F incrementing path. Here's one of them. The path is given by X followed by D, and then C, and then Y. Again, all the arcs are forward arcs, and the current flows on every one of them is strictly less than the capacity. Again, the residue capacities are 3, 1, and 3. There are no reverse arcs, so epsilon Q is just 1. Hence, we can increase the flow by 1. And by doing this, we have the following revised flow. So currently, the value of the flow is 2, right? Because the net outflow from the source is 1 plus 1, which is 2. Is there any more F incrementing path? Let us see. So suppose I start from X. Well, any F incrementing path must start from X. We can go to either A or D. This is allowed because both arcs from X to A and X to D are not yet saturated, right? Because the current flow is still strictly less than the capacity. So let me write down here. It's possible that we go from X to A or going from X to D. Now, suppose we go from X to A. Okay, suppose we are here. Then we can't go from A to B because the arc has been saturated. The flow is exactly the capacity. What about going from A to D? Yes, we can, right? Because the current flow is 0, which is strictly less than 2. So we can go from X to D if we wish. Right, so this path is still unsaturated. Now, after coming to D, there's nowhere else we can go because the arc forward, the arc going to C from D, has been saturated. So we'll be stuck at D and will not be able to reach the sink as we wish. and therefore there is no f incrementing path. Do you follow me? Well, at least when we go from x to a in the beginning. What about going from x to d in the second case? Well, if that is the case, then as before, we can't further going down the arc from D to C because the arc has been saturated. Also, we can't go from D to A. You see, if we want to go from D to A, this will be a reverse arc. Now, we can only do this if the flow of the reverse arc is not zero. But unfortunately, you see the flow along this arc is zero. So I can't go from D to A. And hence I'll be stuck at D, and as before, will not be able to reach the sink Y, and hence there will be no F incrementing path. Okay, in other words, all the vertices which are reachable from X via unsaturated paths are just A and D, and X itself. So there's no way we can find any more F incrementing path. And hence, the Ford-Fulkerson algorithm will terminate here and return the max flow, which is equal to the value of the flow, well, which is the net outflow of the source. But as we can see from the diagram, the net outflow from the source is 1 plus 1. There is no net inflow. Well, there's no inflow into the source, so the max flow is 2. Okay? Let us move on to the second network in part B. Now, the Ford-Fulkerson algorithm will terminate right away for this network. Although the current flow, as we can see as given, is actually 0, because there are no F incrementing paths. And hence the max flow in this network is just 0. Let us see why there are no F incrementing paths in this network. So suppose we start from the source X, and let us try to move from this vertex X via unsaturated path. Well, we can either go from X to A, or we can go from X to C. So let us denote this vertex as C. This is because both the arcs from X to A and X to C are unsaturated, since the current flow are 0 and they are strictly less than the capacity. Okay? Let us suppose we come to the vertex A from X. So suppose we are here. Can we go further using unsaturated path? Yes, there are two possibilities. We can either go from A to B or A to C. Right, so these are the possible paths that we can branch out from the vertex A. Let us suppose we come to the vertex B from A. This is possible because the arc is unsaturated, the current flow is 0 and is strictly less than the capacity. Now, after coming to B, we will be stuck. This is because there are no outgoing arcs from B. That's for one. And also, all the incoming arcs have 0 flow, which means we can't even use any of these as reverse arcs. Remember, if we want to use reverse arc as unsaturated arc, then the flow must be non-zero. So that is not possible over here. And hence, the unsaturated path started from X in this case will terminate at B, which means we can't go which means we can't reach the sink, and hence there's no incrementing path in this case. What about the case of C? Suppose we come to the vertex C from from A. So let's say we are here. We can still go further by using the arc CB. Okay, this is because the current flow on CB is 0 and is strictly less than the capacity. So from C we can come to the vertex B. But we can't go from C to D, because if we were to go from C to D, we have to use that arc as a reverse arc, but the flow is 0, and hence it wouldn't be unsaturated. Okay. For the same reason as before, once we have come to the vertex B, we will be stuck, and hence there will be no F incrementing path in this case, because we can't reach the sink Y from X. Finally, we are left with the case when we go from X to C. In this case, we can still move from C to B, right? Because the arc, well, this can be considered as a forward arc, which is unsaturated. Then after coming to B, we can't go anywhere else because we have all incoming arrows with 0 flow. Okay. Now, instead of going to B from C, can we go from C to A or C to D? Well, that's not possible because either arc, CA and CD, will be a reverse arc, but then the flow in these arcs are 0. So we can't use this as reverse arcs which are unsaturated. So this would be the only unsaturated path from X going to C and then to B. And hence, we have exhausted all the cases. Therefore, there will be no F incrementing path starting from the source X, ending at the sink Y. That is why the Ford-Fulkerson algorithm has to terminate right away from the start. Okay? As mentioned, the max flow is clearly 0 in this case. Okay, let us now move on to the network in part C. Okay, let us start by finding an F incrementing path from the source X to the sink Y. Well, one such path is given by the following. Okay, it's the path starting from X, going to the vertex C, and then to the vertex B, followed by A, and then E. Let me label this vertex as E, and then to the sink Y. Okay, let us check that this is indeed an F incrementing path. The first arc is a forward arc, and the residue capacity is 3. Okay, the current flow is 6, and is strictly less than the capacity. So let me write down the residue capacity for the first arc over here. The second arc, from C to B, is also a forward arc of the path, and the residue capacity is 3 minus 1, which is 2. So this is unsaturated. Now the next arc is a reverse arc, okay, because we're going from B to A, opposing the direction of the arc. And for this arc, it is unsaturated because the flow is 4. Okay, as long as the flow is not 0, we are fine. So it's a reverse arc, and the flow is 4. Next, the arc from A to E is a forward arc, and the residue capacity is 3 minus 0, which is 3. And finally, the last arc from E to Y is a forward arc again, and the residue capacity is 12 minus 5, which is 7. Epsilon Q in the last column here is just the minimum of all the numbers in the second and the third column. So this is the minimum of 32374, which is 2, of course, which means by Ford-Fulkerson algorithm, we can increase the value of the existing flow by 2. So let's push an additional 2 units of flow along this path. For the first arc, the flow will increase from 6 to 8. For the second arc, the flow will increase from 1 to 3, thus making this arc fully saturated or fully utilized. And the next one. Okay, the next one is a reverse arc. So we are pushing back 2 units of flow along reverse arc because there is a 4-unit flow currently along the arc. This will be reduced to 2. You follow me? Then along AE, the flow will increase from 0 to 2. And finally along EY, the flow will increase from 5 to 7. Okay, because we are increasing by 2. That would be the revised flow of the network. Let us now see if we can find any other F incrementing path. Indeed, there is one starting from X, going to A, and then E, and then the sink Y. Let us check. From X to A, the arc is an forward arc, and the residual capacity is 5 minus 4, which is 1. The second arc is another forward arc, whose residual capacity is 3 minus 2, which is 1. And finally, the last arc is another forward arc, whose residual capacity is 12 minus 7, which is 5. There are no reverse arcs. Therefore, epsilon Q is the minimum of 115, which is 1. And now we can revise the flow by increasing the existing flow along the path by 1. This means the flow of 4 here will be increased to 5. The flow along AE now becomes 3. And then the existing flow from E to Y now becomes 8. All right? Okay. Let us now see if there are any further F incrementing paths. Well, if there's such a path, then it must move from X to Y. You see, the arc from X to A is already saturated. So let us see if we can move from X to Y via unsaturated path. So from X, the only place to go is C, because that is the arc which is not yet saturated. From C, we can either go to B or to D, since these two arcs are not yet saturated as forward arcs. So we can go from C to B, or we can go from C to D. These are the two possible branches. Let us suppose we go to the vertex B. Okay. Now from B, we can't go to the sink Y because the arc is saturated. We can go from B to A by using the arc as a reverse arc. This is allowed because the flow along the reverse arc here is not 0. So it's possible that we go from B to A. This is considered unsaturated. But after coming to A, we'll be stuck because we can't go from A to E since the flow is maxed out already. And then we'll be stuck at A. So that is the scenario in the first case. The second case, if we were to go down to D from C, right? If we are here at the vertex D, then we are stuck again because the only arc now is the arc from D to E, but that one is maxed out already. So in all cases, we will be stuck because we can't reach the sink Y. You follow me? Therefore, the Ford-Fulkerson algorithm will terminate right here. And let us calculate the maximum flow. The maximum flow is the net outflow from the source X. Okay. There are no incoming arrow into the source X. So this number here is 0. The flow out of X are 5 and 8 together. So the max flow is 13. Okay guys, that's all for question 1.